Here's a number that changes every year, your age. Last year it was one thing, this year it's another, next year it'll be different again. But here's something that doesn't change, the gap between you and a sibling born exactly 3 years before you. They will always be 3 years older. Always. One of those quantities changes. The other stays put. By the end of this video, you'll be able to speak the language algebra uses to describe both and read inequalities, expressions, and equations like a fluent reader. Let's start with what changes and what doesn't. In algebra, a quantity that can change value is called a variable. A quantity whose value always stays the same is called a constant. Since variables can take different values, we use letters of the alphabet to stand in for them. The letters you'll see most often are X, Y, A, B, and C. So if we call your age G, then your sibling's age, always 3 more, becomes G plus 3. The letter G varies. The number 3 stays put. Now we need symbols to do things with these letters. You already know the 4 basic operations from arithmetic. Let's see how algebra writes them. Notice one thing missing, the cross symbol for multiplication. In algebra we avoid it because once we start using the letter X, the cross times sign is too easy to mistake for it. So instead, we use a dot or parentheses. 2 little words help you translate algebra into English, of and. The product of 6 and 7 means 6 times 7. The quotient of 20 and 5 means 20 divided by 5. The words of and point you to the 2 numbers. Let's try translating in the other direction. Look at these 4 and read each one aloud in plain English. Try them yourself before I read the answers. Here we go. 12 plus 14, the sum of 12 and 14. 30 times 5, the product of 30 and 5. 64 divided by 8, the quotient of 64 and 8. And x minus y, the difference of x and y. Now, what if we want to compare 2 quantities instead of combine them? When 2 things have the same value, we connect them with an equal sign. When they don't, we use an inequality. The number line makes inequalities easy to picture. Numbers grow as you move right. So if A is less than V, that just means A sits to the left of V on the number line. If A is greater than V, then A sits to the right. Here's a trick for remembering the symbols. The less than and greater than signs each have a small pointy side and a wide open side. The pointy side always points to the smaller number. The wide side opens toward the bigger one. The mouth eats the bigger number. Algebra uses 6 comparison symbols you should recognize on sight. Equal, not equal, less than, greater than, and the 2 combined symbols less than or equal to and greater than or equal to. Let's read a few. 20 is less than or equal to 35. 11 is not equal to 15 minus 3. 9 is greater than 10 divided by 2. And x plus 2 is less than 10. Notice that last one mixes a variable in with the comparison, perfectly legal in algebra. Let's put this to work with something real. Cars get rated for fuel economy in miles per gallon. The Toyota Prius gets 48 miles per gallon. The Mini Cooper gets 27 miles per gallon. Which symbol goes between them? 48 is bigger than 27, so we use greater than. The wide mouth opens toward 48. Try this one yourself. A Nissan Versa gets 26 miles per gallon. A Honda Fit gets 27 miles per gallon. Which symbol? 26 is less than 27, so we write 26 is less than 27. And if 2 cars tie, say both get 27 miles per gallon, we use the equal sign. Now for one of the most important distinctions in all of algebra, the difference between an expression and an equation. Think of it like the difference between a phrase and a sentence in English. A phrase expresses a thought but doesn't make a complete statement. It's missing a verb. A sentence has a verb, so it makes a complete claim. Algebra works the same way. An expression is a number, a variable, or a combination of them with operation symbols, but no equal sign. It's incomplete on its own. An equation is two expressions linked by an equal sign. The equal sign is the verb. It says, these two things are the same. Let's test it. Look at these four. Which are expressions and which are equations? Hunt for the equal sign. Number 1 has one equation. Number 2 doesn't expression. Number 3 doesn't expression. Number 4 has one equation. The equal sign is your single clue. And that's the language of algebra in a nutshell. Variables for what changes, constants for what stays put. Operation symbols with the dot replacing the cross. 6 comparison symbols for equality and inequality. And the big idea that an expression is a phrase while an equation is a complete sentence. Next time, those expressions can get tangled fast. What happens when we add a tiny raised number, called an exponent, and a strict set of rules for which operation to do first?